Hi class, we are now on chapter 8 and we're going to be covering quantities and chemical reactions. There's a fancy word called stoichiometry. That's what we're going to be learning. First section talks about carbon dioxide, and I'm going to cut this short here. The greenhouse gases that surround Earth, they are not a bad thing. They are a good thing. They keep us warm. It's like a blanket. However, the problem is that there is heat that's supposed to be allowed to leave, and it can't. So what happens is that you see it gets bounced back because of the fact that we have too much CO2 that's being generated, more than what we should. And every year it's more and more, so it's heating the Earth twice. So the heat comes in here, it bounces out, it should leave, it doesn't, it comes back and it's heating the Earth. This is why there's a concern with CO2. So how do they know this? Well, there's a reaction about, one of the things about is a gasoline. This is based on the CO2 generation is because of the fossil fuels that are used. CO2 is produced, for instance, in this reaction from octane. For every 2 moles of octane that is used, it produces 16 moles of carbon dioxide. So we can take this information and they can determine that the amount of CO2 generated is from the amount that is from the fossil fuel combustion. So long story short, what this is trying to link up is stoichiometry. How can we take a balanced reaction and determine the amounts that are being used? For instance, if we want to know how much of a product is going to be produced from this, how much of a reactant we need, how much does the reactant excuse me, my mind just went blank. How much of that reactant reacts with another reactant? So we're going to start out slowly, so to help you understand what this is before we actually go into balanced chemical equations, which is what we're going to use. So a recipe gives a numerical relationships. So if we want to make 5 pancakes, you can see we need 1 cup of flour, 2 eggs, and a half a teaspoon of baking powder. So 5 pancakes, you need 1 cup, or 5 pancakes, you need 2 eggs. 1 cup of flour. 5 pancakes, you need half a teaspoon of baking powder. This is very similar to a balanced reaction, a chemical equation. We have reactants, we have a product. So in this balanced reaction, you can see the numerical relationships that are needed in order to produce these 5 pancakes. We have the 2 eggs and everything else to make the 5 pancakes. So there's a ratio here. So we have a ratio of 2 eggs for 5 pancakes. We have a ratio of 1 cup of flour for 5 pancakes, half a teaspoon of baking powder for 5 pancakes, or we can even use the reactants. We have 1 cup of flour for 2 eggs. So we can jump in between to show the information that we get from there. But what if we have 8 eggs? How can we determine how many pancakes we can make from 8 eggs? And this is stoichiometry. We can use that balanced reaction of pancakes, and we can see that we need 2 eggs for 5 pancakes. So we can set this up. We have 8 eggs. We take the ratio of the 2 eggs to the 5 pancakes. We set the eggs units on the bottom because we can cancel out those units, and it leaves us with the units that we want. And then we multiply. So 8 times 5, and then divided by 2, or however you want to do it. Some people may want to do 8. This could be parentheses on a calculator, 5 divided by 2. It ends up with 20 pancakes, and the units of eggs are now gone. So if we have 8 eggs, we can produce 20 pancakes. That is now setting up for the next section to elaborate and make the connection into chemistry.